everyone. So for grade 6, what are we doing is that we have this chapter 6, section 1 for Earth movement in space. There are two types of movements that actually the Earth takes place. It's called your rotation and your revolution. First, we'll cover the rotation. Remember, whenever I'm teaching to my students, I'm teaching them when the student is right, like we're having an online class. So what happens there is that we're discussing. Either they study the ebook beforehand and we discuss it with each other, or they bring questions and then we study them and relate them to real life situations so they have a better understanding of these things, right? Because what is science? It's just trying to understand what is happening in our nature. Now remember, let's understand this. What is rotation? A planet's Earth is not a stationary object around which other is not a stationary object. So what does that mean? That it's always moving. Now the Earth has different type of movements. One is called Earth's rotation is the spinning of Earth on its axis. So it's spinning. You see that? You see that line that's going from the North Pole to the South Pole. Sorry, it's not a straight line, but it's going from the North Pole to the South Pole. What is the significance of this rotation? The significance is that it has a daylight and it has a nighttime. Now, why does that happen? You can see also outside whenever it's usually what happens. 12 hours daytime, 12 hours nighttime, and here the rotation takes place in 24 hours. These things are important because it will help you differentiate between the movement of the Earth. So we covered that. The alteration of daytime and nighttime. As the Earth rotates on its axis, different sides of the Earth face the Sun. Earth makes one complete rotation around the Sun, right? So why is that important? Because whenever the side of the face that is actually in front of the Sun, that is the daytime. The one that is hidden is called the nighttime. I hope rotation is done. Like rotation is complete for you. Rotation is the movement of the Earth on its axis. First point. Next point, it takes 24 hours. It takes 24 hours for it to have one complete rotation. Next, there is a part of the Earth that faces the Sun. That's called the daytime, and the one that's hidden is called the nighttime. Okay. So all of these are it's more specific like details of the rotation. If I miss something or you don't know about it, tell me in the comment section and I will be sharing my number, so directly contact me there because it's final time and I usually miss messages or I can't comment on time. So let's go to the next one. Earth also revolves around the Sun. So whenever the Earth is also revolving around the Sun. Now, revolution is just movement of one body in space over around another one. That's called revolution. It's not just about the Sun. It's a lot of bodies in the space that one body is revolving around the other one. So the Earth, when it's revolving around the Sun, it takes it 365.25 days or 1 year to revolve. Earth's revolution around the Sun is an orbit. So it's an orbit. You can see that here as well. The pictures are really good. You can see it from here. This is an orbit. You understand? This is an orbit. It takes 365.25 for the Earth if it starts from here. It will take 365 days for it to come here, to end here. Okay? The next thing is that the Earth revolves around the Sun in an orbit. Earth's axis is tilted to an approximate angle of 23.5. What do they mean? That there is always a tilt. There's a tilt away from the Sun, there's a tilt towards the Sun. So always this happens. I hope you remember that we studied this in grade 5 about seasons as well. So as the Earth revolves around the Sun and due to tilt of the Earth's axis, different locations on Earth receive varying amounts of direct sunlight causing seasons. There you go. They mentioned the seasons here as well. That because of this revolution and due to the tilt of the Earth's axis, both of these things, different locations on Earth, remember, whenever we have summer in Middle East, it's not a must that we have a summer in other countries. So right now in Australia, it will be winter. Do you understand? So because of these locations and the tilt of the Earth, if it's towards the Sun or away from the Sun, that also tells you about the sunlight and about the seasons of that time. Let's go to the next one. I hope you understand about the revolution. Let's go to the next part. The moon. The moon is also a round rocky body. The moon rotates. I mean, the moon is like they really hit it there. Let me just circle it so everyone can see it. Okay, it's right here. The moon rotates on its axis. Now look, it's rotating and it's revolving. Both things. The same thing as the Earth was doing. It takes almost 27 days for it to revolve around the Earth once in almost 27 days. It will be seen from the Earth as a lit object in the nighttime. But remember, moon does not have its own light. What happens? It reflects the light from the Sun. Let's go to the next part. So we're done from the first paragraph. Let's go to the next part. Now the phases. We have studied these phases when you guys were younger as well. I think in grade 4 and grade 5, but I think this is a more detailed part of it. Whenever you have much like the Earth, only half of the moon is always lit by the Sun. Okay, so remember, the moon is only reflecting the light. So the light it's coming that we see from the moon is actually from the sun. So sometimes only half of the moon. You can see this. Okay, better there's a drawing down here. Let's just refer to it. Better there is what? That the phase of the moon as seen from the earth depends on how much of the lit side of the moon is visible from the earth. So how much lit side of the earth we can see. That is it. The phases are just dependent on how much of the moon we can see. Okay. In here, we can see this part of the moon from the earth. So we see it as first quarter. You understand? Then we start seeing it more. Okay. Let's continue from it. So in the new moon phase, let's go to the new moon phase here. Okay. And then I'm going to follow how the text is going to, so it helps you understand whenever you're reading as well, so it becomes easy. The moon is visible from the earth. So here, the moon is visible from the earth. The lit side of the moon faces away from the earth in this phase. So the lit side faces away. You can still see the moon, but it's facing the lit side, the shining side is away from the earth. As the lit side of the moon becomes visible from the earth, increases in size. So now what is happening? We are going and the light is starting to appear on the moon. We can see the moon more, like we can see it more visibly. The moon is always present, but sometimes there is more light on it, so we can see it in different phases. As the lit side of the moon becomes visible from Earth, increases in size. So now look, it's increasing in size. Now we can see more of the moon. You see that? As you can see from the new moon, it became more, you could see it more clearly, then more clearly it became the first quarter. The first quarter phase of the moon occurs while the moon is waxing. What does waxing means? It means it becomes bigger, because for us, the more light will be shown on the moon, the more we will see it as bigger. The moon continues waxing until its whole lit side is visible from the earth. What are they talking? So it's waxing. This is waxing, right? Remember, it's becoming even more visible. Here, it became the full moon. Now you can see the whole moon, right? So after this phase, after we have gone from the new moon where we could not see anything, then we started seeing a little bit, and then the more, and then we could see half of it. It became the first quarter, and then we continued, waxing continued, until we could see the full moon. Now, after the full moon, what happened? After the full moon, it started to hide again. Okay, after this phase, the visible part of the lit side of the moon began to decrease. Now look, it's decreasing. It's decreasing. For a third quarter, it's decreasing. This is decreasing, decreasing. Now it became hidden again. After the phase, the visible part of the lit begins the size to decrease, and it's called waning. And then it hides again. During this period, the third quarter phase of the moon occurs before the new moon arrives. So this one is the third quarter. Now, what is the third quarter? This is when before the new moon occurs. You understand? So the phases are like this. Again, grade 6. Let's understand it. New moon, nothing is shown. We cannot see the visible side where the light is shining on the moon. We cannot see it from the earth. Remember, all of these phases are reference to you that you could see it from the earth. Then waxing started happening. What is waxing? Is that more of we could see the side of the moon where the light was, where we could see the moon where the light was. And then the first quarter, we could see half of the moon. Then what happened started to increase more waxing happened until there was the full moon. After the full moon occurs, they start to decrease again. So new moon, first quarter, full moon, and then it starts to decrease again. Now when it starts to decrease, look, now, what do we mean by decreasing? Now from the earth, we can see the part of the moon where there is less light. Then it's decreasing, then the third quarter happens. Now the half of the moon is being shown. Now look at this. First quarter, we could see this part, the right side. On the third quarter, we can see the left side. Again, it's decreasing until it becomes the new moon. So it's a phases. They are all a circle, which it continues like a cycle. So eclipses. Now remember, eclipses, I know everyone knows about eclipses, but there are two types, the lunar and the solar eclipses. Let's see what is it. Usually, when an object on Earth blocks the light of the sun, they're trying to explain to you through shadows. If you're standing in front of the light, right, at night, you see that whenever there is a source of light, any bulb in your class, you won't be in class at night, but in your room or outside on the street, you'll see when you block the light, it will form a shadow. That is what eclipses is also. An eclipse is a partial total blocking of the light of one celestial object by another. So what happens? An eclipse is a partial or total blocking of the light of one celestial object by another. Now, for example, there is a sun. If the moon is blocking the light of it, or the earth is blocking the light of it, that is called eclipses. Okay? I just give an example. Let's see what it really is. On earth, eclipses occurs only at times when earth, moon, and sun. So remember, eclipses is only between these three things that we are concerned with. Earth, moon, and sun. And they are perfectly aligned. So it means they're blocking each other's light. An eclipse can be that of a sun or a moon. So there are two types, the lunar and the solar eclipses. An eclipse of the sun is called a solar eclipse and happens only 2 to 5 times each year. A solar eclipse occurs when a new moon passes directly between the Earth and the sun. For example, I hope there's a picture here so I can show it. Yeah, okay, here. I mean, it's right here. So what happens on the Earth? Eclipses of the sun is called solar eclipse. It happens only 2 to 5 times. A solar eclipse occurs when a new moon passes directly between the Earth and sun. The Earth and the sun, between it, there is the moon. When you have the moon there, it means what is happening? The moon has come in between the sun and the Earth. So what happens? It's blocking the light. Now, when it blocks the light, it forms two things, the umbra and the penumbra. We'll say that later, okay? Let's go to the lunar eclipses now. When this occurs, the new moon blocks sunlight from parts of the Earth. An eclipse of the moon is called lunar eclipses. Now, there is another one. When this occurs, the new moon blocks sunlight from the parts of the Earth. An eclipse of the moon is called the lunar eclipse. A lunar eclipse occurs when the Earth passes directly between the full moon and the sun. So what happens whenever, I hope there's a picture here. Okay, there isn't. But what happens is when the Earth, imagine this Earth came here, between the sun and the moon. This is called the lunar eclipses. And lunar eclipses occurs when the Earth passes directly between the full moon and the sun. Full moon, we keep that in mind. Full moon and the sun. Earth prevents sunlight from reaching the moon's surface. So what happens? The Earth, it prevents the sunlight from reaching the moon. This event takes place once or twice a year. It's just the blocking of light, basically. Solar eclipse and lunar eclipse is just the blocking of light. Let's go to the next part. Let's understand what solar eclipses is in details. Solar eclipses, during a solar eclipse, the moon casts two types of shadows, the umbra and the penumbra. So there are two types of shadows that the Earth has. So whenever you have a solar eclipse, there is umbra and penumbra, the sun, the moon, and then the Earth. The umbra is the very dark part. So all the countries that fall here are completely, you will see dark, because they have completely blocked the sun. So you will see completely dark in this area. It's called the umbra. I don't know what you guys call it in school, but that's how we used to pronounce it when we were studying it. A total solar eclipse, where the sun is entirely obscured. So the sun is completely being blocked by the moon. And then the penumbra is the lighter. So you'll see a bit of light. It will be not as dark as the umbra part. Moon's shadow, where only a portion of the sun is blocked by the moon. People with the penumbra see a partial solar eclipse, and the other part, they see a full solar eclipse. Now what happens, keep in mind, people, whenever they say penumbra, right? Penumbra, they will see a crescent shaped, creating the covered moon. So where the sun is partially covered by the moon, it's creating a crescent shaped. Okay, just that. Now what is a crescent shape? It's like this. You see it like this. It will be like this. The next part, additionally, a third shadow cast by moon is called the antumbra. This shadow occurs during annual solar eclipse. In this case, the moon is too far from the Earth to completely cover the sun and resulting in a ring of the sunlight visible around the moon. So additionally, a third shadow cast by the moon is called the antumbra. So you see this antumbra? It's like this. Now what happens here? This shadow occurs during an annual solar eclipse. So it occurs during an annular solar eclipse. In this case, the moon is too far from the Earth to completely cover the sun. So here it's too far away. The moon is too far from Earth to completely cover the sun, resulting in a ring sunlight visible around the moon. So just the distance is very far. Let's go to the next one. And remember, it's just the moon is just too far away from the Earth to cover the sun completely, so it forms a ring. Lunar eclipse, when the Earth passes directly between the sun and the moon during the lunar eclipse, Earth casts a shadow on the moon. So now what is the lunar eclipse? The lunar eclipse is just, look, you can see it here, that the Earth came in between the sun and the moon. When the Earth passes directly from between the sun and the moon during lunar eclipse, Earth casts a shadow on the moon. So what happens? The Earth is actually blocking the light now, so it's causing a shadow in here. That's it. Which causes it to darken, often take on reddish color. So now what happens is that it darkens it and it causes reddish color. Lunar eclipses are of three types: the total lunar eclipses, the partial lunar eclipses, and the penumbral lunar eclipses. So there are three types, okay? Total, partial, and penumbral. In total, in the complete lunar eclipses, the entire moon is being passes through the Earth's umbra. So everything is dark. Like here, everything is dark. None of the light is being passed onto the moon from the sun. Nothing. During the total lunar eclipse. Scattering of sunlight. Okay, the moon can appear red due to scattering of sunlight through the Earth's atmosphere. So it can appear a bit reddish because it has some of the light that is passing through, but it's in the darkest part of the Earth. So because the size of the sun is much bigger, so some of the light is passing through. In partial lunar eclipses, only a portion of the moon enters the umbra. So in the partial lunar eclipse, only some of the moon is entering the dark part of the Earth. The rest of the moon remains in the penumbra. So the rest of it remains in the lighter part. The outer part of the Earth's shadow. Only part of the moon darkens, and as the Earth's umbra covers a portion of the moon, it appears though as a dark bite has been taken out of the moon. So only part of the moon darkens, and as the Earth's umbra covers a portion, it makes like someone bit on the moon. It seems like that, because some of it is covered and some of it is not covered. This creates a crescent-like shape similar to the moon's face. In penumbral lunar eclipse, the moon passes through Earth's penumbra. So in the penumbral lunar eclipse, the moon passes through the Earth's penumbra. The shadow is subtle and the moon only slightly darkens. Now penumbra is the lighter part. Remember we studied it in the previous sun one as well. The shadow is subtle and the moon only slightly darkens. So here the moon is not completely dark, it's only a little dark. So making this type of eclipse very less noticeable. So it's not very noticeable in this phase. And now you can see this total lunar eclipse, it becomes a bit reddish. Some of the sunlight is being hit, but very less, very, very less. Partial lunar eclipse, this part is in the umbra part, which is entirely the dark part of the Earth, where it's covering it entirely. The moon is in the dark part of the Earth. It's blocking all of the light from the sun. This one, penumbral, some of the light is coming through, some of the light is not coming through. It's just as if it's not even eclipses. Okay. So unlike solar eclipses, you do not need special eye protection for lunar eclipses. Let's go to the tides. The tides actually are dependent on the moon and the Earth. So whenever you have a tide, the moon, Earth, and the sun, but the sun, it does play a role, but not a very strong role in this. So the water levels, they rise and fall in a regular pattern in 6 hours and in the next 6 hours. So the water level in large bodies of water changes during the course of the day. A tide is a regular rise and fall of the level of ocean or sea water that occurs every day. So what happens is going up and it's going down. That is when the tides happen, right? The water level rises for almost 6 hours and then falls for the next 6 hours in a regular pattern. The pull of gravity between the moon and Earth is the main reason for tides. So the pull of gravity so there is a pull of gravity between the moon and Earth. You'll understand that later on. That, causes the tides. Gravity is the force of attraction among different objects. So gravity is what? Gravity is dependent on two things. I hope you guys remember it from grade 5 and grade 6. That gravity is actually the distance and how heavy an object is. So the bigger the object is, the more gravitational force there is. The smaller the distance is, the more gravitational force there is. Okay, so keep these two things in mind and the phases for the next to understand tides. The pull of the gravity is also affected by the distance, like I explained, the smaller distance and the greater pull of the gravity. So the smaller the distance, the greater the pull. For example, if you have two objects that are closer together, the gravity pull will be stronger than an object which is far away. Okay? Okay, let's go to the next one. So you see this seashore at a high tide and seashore at a low tide. The moon's gravity pulls the water on the side of Earth facing the moon towards it. So the moon's gravity pulls the water on the side of Earth. Okay. Whenever, remember, there are places that the moon has is closer to the Earth, so there is more gravity pull. Remember the distance, right? And sometimes it's away from the Earth, so it pulls on other things. So it's a process of pulling. So what tide is making. So the moon's gravity pulls the water on the side of Earth facing the moon towards it. So wherever your moon is, why is it a high tide here? Because here the Earth is directly facing it. So here the tides are going to be big, right? On the opposite side, for example, the low tides you can see here and here. What happens here is that it pulls more towards the Earth, not the water. The water is not as close to it as the Earth is, the solid, the ground is. So the ground will be pulled towards it more and the water will be far away. So for example, this is the moon, right? This is, for example, I'll just try to make it good. This is the moon. This is the Earth, okay? Now, it's on this side, the water is here. Remember, the water is here. So on this side, the moon, the effect is going to happen, the gravitational force that's going to affect here. So this is going to be pulled more than the water that is here. So it's going to be a low tide in here. Spring and neap tides. So this is all what we're studying. As Earth rotates, these tides occur daily, remain aligned with the moon. So whatever happens as the Earth is rotating, remember, rotation, revolution, all of those things are still happening. So the tides are going up and down continuously. In these locations, the water level rises. The highest water level at a coast is called the high tide. So at this place, it's called the high tide. At low tides occurs approximately 6 hours later when the bulge of water is receded. So remember, when there is less, there's more pull towards the earth, not the water. At any one time, there are two places on earth with high tides and two places on the earth with low tides. The difference in water level between high tide and low tide is called a tidal range. Okay, I hope this is clear. So the tidal range and everything. Spring and neap tides, the position of sun, moon, earth cause tides to be either strong or weak, though the sun is massive, it is very far from the earth. So what happens, sometimes they're called neap tides. Now neap tides includes your sun inside it. First, when we had normal tides, tidal ranges, we were concerned with moon. But now we have the spring and neap tides. Now what are they? The position of the sun, moon, and earth causes tides to be either strong or weak. Though the sun is massive, it is far away from the earth and the effect is very less on it. So it's not that significant, and that's why we don't consider it as much. A spring tide occurs when the sun, moon, and earth are aligned. You see that? Spring tide? When the sun, moon, and earth are aligned. Spring tide occurs during new moon and a full moon. Okay, so remember, a new moon and a full moon, okay? So during the spring tide, the high tides are very high and the low tides are very low. So there is called a neap tide, and then there is a spring tide. A spring tide occurs when the moon, sun, and earth tides are aligned due to combination of sun and moon's tidal effect. A spring tide occurs during a new moon and a full moon. Please keep these things in mind, and that's why I'm repeating them. During a spring tide, the tides are very high and the low tides are very low. Okay? And okay. Let's go to the next one. A neap tide occurs when the sun, moon, and earth are at right angles. Remember, keep this in mind, on right angles. A neap tide occurs because at a right angle, the tidal effects of the sun and moon cancel each other out. So a neap tide occurs because at a right angle, the tidal effect of the sun and the moon, they're canceling them each other out. A neap tide occurs when the moon is in the first or third quarter phase. During the neap tide, the high tides are less intense and do not significantly differ from low tides. So what happens in neap tide? They're the same. So during the neap tide, the high tides are less intense. So the high tides and the low tides, they seem as if they're the same. I hope you understand this. I've tried to make it as hurry as I could because, I don't want to make the video very lengthy, so it becomes very difficult. If you would like to know something in depth or something I said is more confusing, please comment down below so I can, explain it again. Take care of yourselves. Bye-bye.